Thank you. Thanks a lot, everybody. By the way, we started in English, but just say who speaks English or Italian? Any? Okay, so it's better in English. It seems more hands. Yeah, so we'll go in English. All right. So anyway, thanks a lot. It's a great pleasure. Thanks for giving me the opportunity to be back here. So I want to share with you some of the research we're doing. I think the topic that was given to me was about research, innovation in the built environment in general. And that's what we are passionate about. But before that, I wanted to start with by looking at cities. If you look at cities today, just if you want to remember four numbers, just remember the following: 2, 55, 75, and 80. Cities are only 2 to 3% of the surface of the planet, so very little. They're 55% of the population, 75% of energy consumption, 80% of CO2 emissions. So if we can do something to make our cities a bit more sustainable, that can be a big deal globally. Well, another way to say this is that the big battles we are facing today on the planet are going to be lost or won in our cities. And what can we do today? Well, today there's something interesting which is related to a new hybrid condition. It's about the internet becoming Internet of Things. Another way to say this is that bits and atoms are coming together. And through that, we can really better understand, design, and ultimately live in cities. Data is behind a lot of this. And by the way, as you all know, everybody these days talks about AI, artificial intelligence. But there's no AI unless you got data to train a system. So data becomes the starting point in order to be able to apply AI in our buildings, in our cities. That's what we're passionate about, both with our design office, with our labs, or with the companies that came out of them. And what I want to share with you today is actually the fact that when you look at these two spaces, there's a lot, if you just move around the fair here, you will see a lot of people are looking like at smartness and, on the one hand, and a lot of people are looking at natural material and nature on the other hand. Well, what I would like to argue today is actually that both of them are exactly the same thing. That actually what we need to do is get a better blending of the natural and the artificial world. And actually, in order to do that, we need to play with a big repertoire that goes from data, AI, natural material, and so on. All of those are different dimensions of this kind of higher integration between the natural and the artificial. So first of all, let me tell you how the artificial world, the world of buildings, of cities, of objects, can become something that behaves more like the natural world, again, thanks to intelligence. This is a project we did a few years ago in Turin, Italy. It's actually the Agnelli Foundation. Agnelli Foundation is behind one of the major industrial conglomerates in Italy and in Europe. And what we did here was actually design a building where, thanks to intelligence, sensing, and data, the building would respond in real time to all the conditions inside. So heating, lighting, and cooling would respond to occupancy, to people preferences. And so again, thanks to all of this, the building starts behaving and responding almost like a living being. And that was both in, the building is two parts. One part is from the 50s and 60s that was refurbished. Another part is the historical one, actually the initial building where Fiat was in the early 20th century, which you see here. And there as well, technology can be more or less visible, but again, turns the space of the artificial into something that responds in a more natural way. Another project, it's an old project, something we did in Spain, in Zaragoza, that was at one of the expos. We've been working a lot with expos. In Milan in 2015, in Dubai with the Italian pavilion in 2020. We now just won the French pavilion in Osaka, that's coming up. And this was actually Spain. In Spain, the theme of the expo was water. In the same way as in Milan, it was about food and feeding the planet. In Spain, it was water. And here we try to think about how can we design a building completely made of water to also to show how we can control water by the drop, avoid wasting water, and using, again, an intelligent system to better use a natural material. So the initial idea was something we were discussing with the mayor, what you see here. Imagine you've got like a water wall that becomes alive, that every drop is controllable. The place can be something that opens up when you approach it, as you see the person going through. And again, you use digital and physical together in order to create a responsive living material. The mayor liked the idea, so we got the commission to design the pavilion at the entrance of the expo. There were two pavilions. It was Zaha Hadid New Bridge, and then our pavilion on the other side, allowing the entrance to the Zaragoza Expo. Here is a little video. Okay. As you see, the whole pavilion is made of water. No doors or windows, but when you approach it, it opens up to let you in. Inside also, all of the walls expand and shrink based on how many people you have. The roof is also covered with a thin layer of water. The other thing, that one is the Zaha Hadid pavilion, bridge pavilion I mentioned before. And then if there's too much wind, you can lower the roof to minimize splashing, or at the end of the day, you can actually close the building and the architecture disappears. Hopefully without anybody underneath. The idea is actually, was during the construction, I like this picture. You see the person with a trolley was actually going to the station nearby, a new high-speed train station between, you know, on the line Barcelona, Zaragoza, and Madrid, but actually missed the train to try to figure out what the hell was happening in the pavilion. This was myself trying not to get wet. But when you create buildings, it becomes alive and respond in different ways. Sometimes also the unexpected happen. And what you see here is, is how actually people started engaging with the building, sometimes in new unexpected ways, just, you know, by playing with it and interacting with it. So the point is, again, that the intelligence can turn the world of the artificial into something that responds more like the world of the natural. This is a building, this is a project under construction in Modena. I believe it is the largest cultural center now in Italy, being refurbished. It's Sant'Agostino, a beautiful old hospital. It's been transformed. And what we're doing here, we've been working with Chuck Oberman. Chuck is a colleague at Harvard, but also one of the leading designers of foldable structures in the world. He's the one who works a lot with NASA for foldable, movable, kinetic structures. And what we did on the top of the Sant'Agostino is create this kind of dynamic roof that can open and close, again, like a living thing. So you can use a space. The courtyard of Sant'Agostino is a covered courtyard. The initial idea they had was to cover it fully, but we didn't like the idea to turn it. You know, that place was born initially as an open place, so we didn't like the idea to cover it and turn it all the time into an enclosed courtyard. So it can be both used and closed, but when you can open it, you also go back to how it was in the 18th century, is a totally open place, and many other configurations in the middle, if you just want to protect it from a little bit of sun during the summer. So we like this as a way to actually address what is usually a very, very important problem when you got restoration, which is you need to think about how, you know, what type of condition you're going back to. And in this case, by creating multiple conditions, again, like a living organism, then the building can be both experienced, like it was in the 18th century, or can be experienced in a totally closed configuration or many infinite intermediate configurations as well. Here's a little video on the building. All right, I also thought I'll show you one of the projects we are doing now at MIT, so that's less about architecture, it's more like a research project. But again, that looks at how intelligence, sensors, intelligence, and so on, can turn, in this case, something else like boats and the mobility system into a new type of mobility system in Amsterdam. So we started working with the city of Amsterdam a few years ago, And the mayor initially was very interested in self-driving cars. As you might know, self-driving cars are coming and they're poised to change a lot of mobility in cities around the world. One of the reasons is that you can actually create many more on-demand systems for ride sharing, for car sharing, and so on. But when you look at Amsterdam, the core of Amsterdam is actually mostly water, not much asphalt, but a lot of canals. And so we started thinking with the city about what about doing self-driving boats. Imagine that you got these kind of boats that can be used to deliver things instead of this DHL boat, to move people around, to monitor air quality, water quality. But also think about this like a responsive dynamic architecture. All of them like little pixels that can come together and create like a temporary bridge or a floating platform or something. Again, think about archigram on water that can be constantly reconfigured in different, in infinite ways. And by the way, this is nothing new. Is what, for instance, if you think about doing a temporary bridge, is what the beautiful city of Venice has been doing for a long time during the Festa del Redentore. But it's usually the beauty of technology that allows us to do something that maybe we always wanted to do, but we can do it finally in a new, in a better, or in a different way. So I just want to share with you how we developed this. This project is going to be premiere at the Olympics in Paris next year. So it will be both used and tested and premiere again at the opening. What you see here, this was the first model, very, very small, with different type of propulsion, as you see here. Again, this is 1:4 scale. This was being tested in the canals 3 years ago in Amsterdam. Very flexible, can move in one direction, the other direction, symmetrical, can also move laterally, as you see. We told the mayor, even if the research project fails, we'll open a toy company because everybody seems to have so much fun playing with this on the canals. So this was a small one. When you're doing this, you also need to collect a lot of data about everything around. So there's actually mapping in real time all the other boats in Amsterdam. That's data, if you're doing self-driving cars, you usually have it. You can get it from Google and similar platforms, but not on the canals. So you actually need to build that infrastructure yourself. This is actually how a robot sees a city. That's using LiDAR data. So every second you got 300,000 data points that describe in 3D with a precision of 1 millimeter all what is around. If you want, this is the artificial eyes that more and more guide our self-driving cars, our self-driving boats, or a lot of the things we are developing in construction, on construction sites, and so on. By the way, there's a lot of this also here at the fair. You can see how measuring in real time very, very precisely becomes a very important step in making sure that what we design digitally makes it into the real world. And incidentally here you see you use this in order to guide the robot, but then the robot, the boat also allows you to collect all this data, so you also becomes a way to better understand and describe the city. So there's a value not only in the movement of the boat, but also there's a value in the knowledge you're collecting about the whole city. And then when you got this thing, you can program the system with artificial intelligence to avoid obstacles. Is what you see here. Different type of obstacles, simple fixed obstacles, as you see here, or very complex ones, as you see here. This is Wei Wang, one of our researchers. He was promoted after this experiment. And here you see actually all of what is behind, how the data becomes the starting point to program the thing. And this is where we stand now. Again, is self-driving boats made it to reality, and you will see this next year at the Olympics in Paris.
The existing infrastructure of many cities struggles to keep up. Robots offer a solution by moving road traffic to the water. By bringing passengers from A to B, or as an on-demand boat, taking you anywhere you want. And they can also help the city as a multi-purpose workboat. Take Crystal. She is equipped to collect household waste to free the streets from heavy garbage trucks. Robots are fully autonomous, so they navigate without a skipper and can operate 24/7. In order to sail by themselves, rowboats need to perceive their environment and recognize objects such as bridge pillars, floating objects, and of course other vessels. The primary source of information comes from a LiDAR sensor, but rowboats are also equipped with cameras, GPS, and a digital compass. Rowboats onboard computer combines and processes all of the data and runs the rowboat software so it can successfully complete its mission plan. After 5 years of development, testing and experimentation, we have now successfully enabled autonomy in the full-scale prototypes. Rowboat is ready for the next step. Join us and let's unlock the potential of urban waterways together.
All right, so this was just a few examples of how we can actually use intelligence data technology to turn the artificial into something that behaves in a much more similar way to the natural world. But actually, there's the other thing as well, as I said at the beginning, is actually how we can embed more nature in our cities, in our buildings. And that's kind of the other thing, part of this co-evolution we were saying before. And that idea of the relationship between the artificial world and the natural world is an old long-standing idea. What you see here, for instance, is Broadacre City by Frank Lloyd Wright. And that idea was, well, why don't we move the city outwards into nature to create a better blend between the two? Unfortunately, as we all know, this idea, the poetic idea of 100 years ago ended up in something like this. So little by little, we actually destroyed a lot of the nature that was outside of our cities. And so I think the challenge we have today is actually how we can bring nature, or the thinking of nature, the thinking of circularity, and the principle, the nature itself, but also the principles behind nature in the middle of our cities. That's an old project we did. It was the first design in Italy by Patrick Blanc. As you might know, Patrick Blanc is a French botanist, developed a way to grow green on a vertical wall in Paris first. This was the first project with Trussardi in Piazza della Scala, is still there. The idea to create a little green oasis in the center of the city as a place where you can go and meet. Like, we like the idea of an urban living room where people could go and meet and share time together, work, of course, eat something together, by changing in a place that changes with the light every hour of the day based on how this kind of green cloud is designed at the top. This one is one of the large projects here in Milan. It's called Milan Innovation District, the former site of the World Expo. And what you see here is the Decumano. Now, we did the master plan. We won the competition with Lend-Lease to convert it into mine. Now we are working on the University of Milan, the new campus, but also in the overall master plan, the idea is that the Decumano, the main axis, can become a green connector that again allows people to go there, to use it as an outdoor office when the climate is good, and so it becomes this kind of spine that connects all of the buildings, the university buildings, the company buildings, and all of the other innovation buildings for startups, incubators, and so on. This is a project that we just finished in Singapore. It's one of the tallest buildings in Singapore. And here as well, in the middle, you got, this is called Capita Spring. Capita because it's designed for a company called Capita Land, and Spring because of the spring in the middle. And that spring in the middle is like a green spring. And think about it like a vertical plaza in the middle of Singapore. And at the top, you got a headquarters of a major corporation. On the lower part, you got service apartments. And that plaza becomes a gathering point where people can come together, you meet other people, you can go and work, and also you meet nature in the middle of the building. So the building opens up, again, like an organic structure in order to allow nature to come in and create these different spaces at different levels. This one I thought today, because it's in Milan, I'll share some other projects about Milan. This is something else we are very excited about. Together, this was a competition we won. 3 architects and 3 developers. The developers, or kind of the clients, were Coima, Covivio, and Prada. As architects, it was our team with Diller and Scofidio and Lipo Lisano. And this is Porta Romana, a big piece of city that's going to be reconnected with the rest. It was a rail yard, so it was something that you couldn't access. And then, but then again, nature used to reconnect it both north to south with a new park, that goes over the only remaining train track that stays in the middle. But also east to west, you got this kind of suspended forest, a bit similar. As you might know, Liz Diller was one of the key people responsible for the High Line in New York. And so the High Line was a bit of the inspiration, this connector east to west, which is a suspended forest, again, where nature connects two sides of the city. And next to it, we are also under construction this other building, which connects different levels of the city with a green spiral that goes all the way to the top. I don't want to bore you too much. We did this, we're working on the same topics in different parts. Well, this is something we're quite excited. It's the first major extension of the master plan, historical master plan of Brasilia, in Brazil, the capital of Brazil. And here we use exactly the same proportions of Brasilia, but try to turn it upside down and again to get a better blend of the outdoor and the indoor, and also nature and the built environment. Brasilia, like many things with a modernist, call it DNA, actually, in Brasilia, traditionally, in the traditional part, you've got a very big separation between the two worlds. And here we try to hybridize them in different ways, even if we kept exactly the same proportions and the same geometries of the original master plan. So anyway, this was some other example, again, that look at how we can go from nature to the artificial. So how we can use nature and the principles of nature in particular circularity. We're discussing it before with Politecnico di Milano in the other pavilion, so we can bring it into city making, into our buildings, into the built environment in general. But the reality, I was telling you at the beginning, we're seeing how you can go left to right or right to left, but actually in all projects, we're seeing more and more a hybridization. And this convergence is really thinking about the future of coevolution between the natural and the artificial world. And so here I want to share with you a few projects. And this was a project in Milan, was just before COVID, the opening act of Milan Design Week, Salone del Mobile, that was in 2018. And here what we did was actually bring a garden in the center of Milan. We wanted to make it sustainable, so the roof has a lot of photovoltaics in order to collect the energy from the sun. And then we wanted to create a garden with 4 seasons at the same time. We like the idea that you could actually move between spring and summer and fall and winter as you're moving through space. So you're moving through space, but it's like a journey through time. Here you see some initial renderings, with the winter and the different seasons. Here you see the built pavilion in Piazza Duomo next to the Royal Palace, with the winter pavilion with real snow inside, done sustainably by actually producing the energy at the top and doing a little bit what happens in your refrigerator when you're producing cool on one side, you're producing heat on the other one, and so you can be circular as well, in quotes, in the way you're managing all the different flows in the pavilion. And here you get, that was a spring. The summer was a very sticky summer, very typical, Milanese sticky summer, very sweaty. And here is a little video. So as you see in this project, you got the two components. You got a component that goes from the artificial to the natural, and natural to the artificial, all together. The project wouldn't work without, clearly without the content and the natural content inside, but also without all the control system and the intelligence that allow it to be alive. Another project we're working on at the moment is today is the largest decarbonization project in the world. It's in the city of Helsinki. And that started as a result of the Helsinki Energy Challenge. Now, as you might know, cities usually are not very innovative. Cities usually, when they need to do something, they look at best practices. But if you think about it, a best practice means that you are looking at something that another city did, maybe with an idea that started 10 or 20 years before, and then it took a number of years to design and then to implement and then to make sure it was successful. So somehow if you think about the best practice, what it does, it actually locks the future into the past because it starts from the past and just look at what was successful. So cities don't have a great record in being disruptors or innovators. In the United States, there's a foundation that actually has a good record for disrupting things. It's called the X Prize Foundation. And what they try to do, the X Prize Foundation, is actually put a prize, usually $10 million, They allow people from all over the world to compete to find new solutions. They get a few finalists, and then they award the prize. And sometimes they got great companies coming out of that. SpaceX and many of the space exploration companies came out of an X Prize that happened a few years ago. So the city of Helsinki did something quite brave. The mayor decided that he wasn't happy with the solution he was being presented, and he decided to do something similar to an X Prize. He called it the Helsinki Energy Challenge. The challenge was quite simple. In Helsinki, as you might imagine, the climate is quite cold, so most of the energy and most of the emissions are related to heating the city. And today you got good news and bad news. The good news is actually the heating happens mostly by district heating. In Italian is teleriscaldamento, so district heating means that basically you're producing power, and with the hot water that you have as a byproduct of power production, you heat the city. Many Italian cities do it as well, and usually it's very good. But as I said, there's good news and bad news, and the bad news is actually most of the power plants in Helsinki are still coal power plants. And so, they're based on coal, and the mayor decided to close them by the end of the decade. So again, he wasn't happy with the solution, so he ran a global challenge that was 2.5 years ago, started. Then over 250 big consortia globally, companies, big multinationals, participate into the challenge, 10 finalists, and then the winners, including our projects that I'm going to show you in a moment. When I said our project is because of something that I think is very important, maybe we can discuss it later, is about everything when you have to innovate needs many disciplines. So our team was, we coordinated the team from our design office in New York. We had many engineers, Rumble, big engineering firm, active globally with a big presence, a big footprint in Scandinavia. Transolar, great engineers from Germany. They are probably #1 in the world for climate engineering. Schneider, SBP, they're also engineers who do very, very lightweight structures. If you want to be sustainable, the first thing is to use less steel, less concrete. And so SBP are probably are some of the specialists for doing this incredibly lightweight structure that many of you probably have seen already, including the one they did at the very beginning. SBP is for Schleich Bergman, the founder. AP is for partners. But the first project by Schleich Bergman was this beautiful structure for the Olympics in Munich with Frei Otto and him that actually is one of the lightest weight structure you probably have ever seen. Then we had some multinational like Danfoss, big multinational based in Denmark, but active globally and doing a lot with heat pumps and all what is related to them. Schneider Electric again, OP with the financial part, or Squint Opera who helped us to actually put together all of the material and make sure it was easy to convey and visualize. Here's a little video. We're excited to present to you the Hot Heart, an innovative solution to decarbonize Helsinki. Here is how we do it. All right, so I want to share this with you also because here as well you see that both the natural and the artificial mix and play different roles. Again, both in the sense of intelligence and in the sense of bringing nature in there. And I want to finish with another project that also uses a lot of the same principle. That's actually the master plan for the World Expo in Rome 2030. As you know, might know, Rome is competing for the World Expo. We'll know at the end of this month if Rome is selected or not. Now, you know, the competition is not about architecture anymore. We are very happy that actually from an architectural point of view, the master plan we did, but when I say we, together with Ricky Burdett and Arup and all the partners, was deemed as, from a technical point of view, probably the top proposal out of the different competing options. But now I think it's in the hands of politics, and we'll see who will win. But I wanted to share with you because here again, what we tried to do was think about two key components. The first one, you know, if you do an expo, making sure that everything that you're doing doesn't go to waste, that every small piece of wood is either reused, recycled, or serves in the long term for, in this case, for the district of Tor Vergata. We also tried to reuse what was there in this place in Rome. For those of you who know the city, there's actually something, what you see there, it's all together team pavilion. It's the Vele by Calatrava, a building by Calatrava that was never finished. So starting from that and completing it, but then trying to turn actually a neighborhood in a district that lacks still a lot of infrastructure. There's a great university, but it is not the underground, the subway. Try to turn that into a piece of city and doing something similar to what Milan did. So next to the university, turn it into an innovation district, making sure that the Expo is only one step for actually a long-term vision for the city, for that part of the city, and for Rome in general. And here is a little video of the project.
Rome, the eternal city, a bridge between the past and the future. Over thousands of years, the city has become home to many different peoples and has been transformed by their diverse cultures, art, and aspirations. In the same way, every place around the world has been shaped by its own unique geography and the beliefs and experiences of its society. Expo 2030 Roma is a chance for people from different territories to come together and share their accumulated knowledge. This international forum will take place to the southeast of the city. The area of Tor Vergata is home to one of Rome's main universities, globally significant research centers, as well as magnificent ancient and modern monuments. The Expo will unite these existing assets into a singular master plan that will transform Tor Vergata into a district of knowledge sharing and innovation. At the crossroads of city and natural landscape, we created a shared space, the boulevard, the world's longest table at which every nation has an equal seat, an equal opportunity to see and be seen, to showcase their perspective to the rest of the world. Each land parcel allows for freedom of design and the expression of a powerful national identity. Each pavilion generates its own clean, sustainable energy and feeds back to a larger grid, the Tor Vergata Solar Park, targeting net zero carbon. Natural and man-made trees are added to the mosaic, providing shade and comfort to millions of visitors. The urban part of the master plan houses all permanent operational buildings. The remaining area is organized into 4 themed parks, showcasing energy, agriculture, water, and history and time. Moreover, 5 landmark pavilions are distributed across the site, each one addressing a key theme of the Expo. The regeneration of existing assets, like the Vele Sport Complex, is part of the zero-waste strategy for Expo 2030 Rome that aims to see not even a single brick go to waste. The event and its legacy will not be confined to the Tor Vergata area. A green and sustainable transport network connects visitors to the starting points of the Expo journey in the heart of Rome. Rome was built by many different hands. So join us now to help shape the next piece in this ever-changing mosaic. Come and be part of our global legacy. Come and be part of Expo 2030 Rome.
All right, and I'll finish here. I think I want to leave like 15 minutes so we can have more like a Q&A, and you know, I could flood you with slides until the last second, but it would be good to actually have a bit of time together and have a conversation. So thank you very much. And if there's any thoughts, questions, just raise your hands. There's a microphone here, so we can. Again, as I was saying, and by the way, if you want, you can ask both in Italian and English. I will answer in English, but feel free to ask in any of the two languages. And as I was saying, you know, again, the thing I wanted to leave you with is this fact, you know, the biggest challenge we have today is really the convergence of natural and artificial, and that happens through many different technologies and many different hands, as you see in some of the projects, and all of them are kind of an experiment for testing this. But yes, I see a hand over there.
Hello, thank you. First of all, thank you for this presentation. We catched it by the end because we were presenting in the Design for Circularity workshop. I would just like to ask a question about the materials that can be used, such as Adobe or mycelium. What's your opinion about converting these into a building or like an urban furniture that can be used for benches, such as this kind of pots? I don't know.
Yeah, and you know, as I was saying before, and I didn't show the details, but in this, let me see if I find a couple of images. But we've done the biggest structure ever in mycelium. That was done here in Milan at the Orto Botanico, 2 kilometers of mycelium to create an architecture made of mushroom, if you want, and then composting it. Adobe is also very interesting, but my point here, I think, is that, you know, as you saw here, I think we need a lot of experimentation. Sometimes we want to use the materials from nature. Sometimes we might just learn from the logic. So even if you use like steel, but we build with nature principles in mind, in a way that everything at the end is reused first, and then if not recycled, but somehow that nothing goes to waste, you know, that's fine as well. So somehow I think we shouldn't restrict our palette. The key point is really, I was trying to make is that in order to achieve this higher integration between natural and artificial, is co-evolution between the natural and artificial world, we really need to look at all the different, at the whole palette. And that palette is a palette that uses artificial intelligence, natural materials, as you're saying, but also sometimes normal material, but used in a way that, again, doesn't, not in a way that, you know, makes sure that nothing goes to waste and that everything is recycled or reused. So somehow we need to be, I think, have a very open approach to this, the ultimate goal being, yes, a better integration between the two worlds. I'll see if there's other questions. I'll see if I find some images of the project with mycelium.
Carlo.
Yes.
Also, thank you for the presentation. I have a question for you, and it may not be a fair one, but I do want your opinion on it. I appreciate the leadership that you're showing in us integrating ourselves into this future that we're seeing that's more green and circular. But reflecting, if you just kind of spin around 360, and you would see what is all going around here and the role of the people making all these products that we have. Because as a leader, you're showing a vision for people, but we need everybody to follow. So I'm not sure it's your role to bring all these people along, but I do want to hear your opinion on how that might happen, because we still have people producing all these other products and they're not necessarily buying into it, and how that might happen.
Yeah, no, thanks for mentioning this. If I understand correctly, is that, you know, yes, you know, but meanwhile we're talking about this, but here just around, there's also a lot of people with very different takes on this topic. But I think that what we can do, and what we can do both as researcher, here I got my hat at MIT, or the research hat, and what we can do also with our hat as practitioners, as architects and planners and so on, is almost like in nature. If you use also the analogy of nature in the process, it's similar to what nature does with mutagens. You know, nature tries a mutation and then see what works, what doesn't work. So I think it is okay. Sometimes, you know, an idea at the very beginning might stay within a certain circle and so on. But the important thing is that if there's value to that, to some of the things we are discussing, to some other things that some of you are discussing here in these days or anytime, you know, that per se is what can start the change you're talking about. So somehow every change starts with this kind of mutation, be it in nature with a small mutation that can then conquer the world, also in the world of ideas, in what we are discussing now, in the world of technology. You know, there's a lot of writing showing that the world of technology actually follows rules that are similar to natural evolution. Again, in technology, if you think about the iPhone was a mutation on a previous type of phone that actually ended up having a huge success because of the things, the new things it enabled. So I would say your point is very important, but I think there's two ways to look at it. One is that, you know, we also become engaged in the politics in order to convince people that this is the right way to go. But I think there's a better way, probably, that we keep on doing what we know best, which is try to develop, again, new ideas, new solutions, test new materials, as was mentioned before, and then some of those things, if there's value to them, will succeed, and then they will, on their own, snowball around. And so I think that's more the take we've been following, both at MIT and in our design office. Yeah. I think you probably have time for one more question if there's one, and I wanted to look at try to find the project I mentioned before to show it to you. Any additional hands, or?
Don't be shy.
Meanwhile, I think I have here the project I want to share with you. Here. Just because of the question before about mycelium and so on. So this was actually the biggest structure made of mycelium ever made of mycelium. Again, 2 kilometers of mycelium. This was in the Orto Botanico, a beautiful place. If you don't know it, in the center of Milan, in the very center, this great natural place in the center. And the topic here was really about circularity. And so we tried to see, can we think about a future where architecture can grow like a plant? And so we've been growing the mycelium in a few weeks before Milan Design Week, and then everything has been composted at the end of the exhibition. So you see here it was clearly a simplified architecture. The reason, by the way, it's the shape is it follows Gaudi shape catenaries because they're pure compression shapes, as any of you who's done structural engineering knows. So basically, inverted catenary becomes a pure compression, so it's easier to calculate, and it's much more stable when you use a material that's still not totally proven in terms of resistance. And then you see some of the things. So, and all of that went back to the soil just at the end of the exhibition. I think that's more and more important, especially for temporary events. I hope that Milan Design Week fairs such as this one, the Expo, the Olympics, more and more will all be designed in a way that all what is built for just a week or a few weeks then is always recycled and reused. So circularity becomes particularly important, especially when you're designing something that only lasts for a limited amount of time. Any additional thoughts? I think we're towards the end, but if there's, I think we've got time for one more question if there's one. If not, I think, you know, we can, well, I thank you very much. Thanks all for coming and for engaging in the conversation, and let's say to be continued. So let's continue talking about it. Thank you.